K-Water is a public company specialized in water resources management. We provide various international water education programs for the developing countries to solve water-related issues all around the world. Today, you will learn the theory and practice on the drinking water sampling method, basic water quality testing, and jar testing. Make sure to wear safety glasses, a mask, protective gloves, lab coat, and safety shoes during the experiment, and practice to prevent contamination when collecting samples and to ensure safety. Let's look at how to sample drinking water first. In order to sample drinking water, various preparations such as gloves, turbidimeter, residual chlorine meter, sterilized sampling container, and brown glass bottle, icebox are required. Then, shall we take a sampling of drinking water? First, wipe the faucet clean to remove foreign substances and dust. Then, light a lighter or torch and sterilize it with flame or alcohol. And open the faucet and let the water flow for 3 to 5 minutes. Rinse the inside of the sterilized sampling container 3 or more times with water from the tap and fill it up. Finally, keep it in an icebox. Now let's take a look at how to measure pH, turbidity, and residual chlorine, which are basic drinking water quality parameters. Let me explain how to measure pH first. For pH, we need pH standard solution, measuring instrument beaker, and stirrer. Before the demonstration, the hydrogen ion sensor should always be immersed and stored in purified water. Turn on the power and let it stabilize for at least 5 minutes before use. First, discard the purified water in the beaker and place the sample. And carefully wipe the purified water on the pH sensor. Put the sensor in the beaker containing the sample and then press the measure button. Wait for reading to stabilize. The resulting value appears as 7.4 after 1 minute. Then put the sensor back in the beaker filled with purified water. Now let's take a look at how to measure turbidity. We need a benchtop turbidimeter and a turbidity cell for measurement. Power on the turbidimeter first and let it stabilize for 10 minutes or more. To use the sample, shake it strongly to mix, and then stabilize it until air bubbles disappear. And put the sample as much as the turbidity cell scale. At this time, we have to pay attention to the external surface of the turbidity cell. Air bubbles on the outside can cause errors in the results, so you need to carefully clean the surface. Then insert the cell and press the on button. When the value is stable, read the turbidity. We will also learn how to measure residual chlorine. Here, we need a residual chlorine meter, DPD reagent, and residual chlorine cell. First, put 10 milliliters of the sample into a 20 milliliter vial with a stopper according to the vertical cell scale. And power on the residual chlorine meter, and then press 0 button on the left to set the 0 point. Add 0.5 grams of DPD reagent in a pouch. After 2 minutes of stabilization, press the value button on the right side of the device. Read the value. Let's look at how to measure alkalinity, which is a measure to determine the level of alkalinity in water. For the test, we need a digital burette alkalinity indicator, Erlenmeyer flask, and 100 milliliter mass cylinder. For alkalinity measurement, first, fill 100 milliliters of the sample into an Erlenmeyer flask using a measuring cylinder, and then add 3 to 5 drops of indicator. Then, turn on the digital burette and press the clear button to initialize the value. When the blue color disappears from the sample filled in the Erlenmeyer flask is the titration point. Jar testing is a pilot-scale test of the treatment chemicals used in a water treatment plant, aiming at optimization of the amount of coagulant injection, optimization of the sequence of chemical injection, optimization of the mixing rate and mixing time, and evaluation of sedimentation and filtration performance. Let's start the jar testing with the sampled water. For testing, we need a jar tester, raw water, a washed 2-liter water storage bottle, coagulant, a pH meter, and a benchtop turbidimeter. The coagulant needs to be prepared in advance at a concentration of 20,000 ppm. First, power on the jar tester. And you need to fill 6 jars with 2 liters raw water using a beaker. At this time, make sure the 2-liter container be washed. Now it is time to inject a coagulant into the raw water. Inject 20,000 ppm of coagulant prepared in advance. Then, quick stirring proceeds automatically for 30 seconds to 1 minute. Next, slow stirring continues automatically. It is divided into 5 minutes at 65 RPM, 5 minutes at 38 RPM, and 5 minutes at 28 RPM. Flocks begin to form, so observe the settling state at this time. And then, put it in a certain place and settle for about 20 minutes. At this time, it is possible to observe a state in which the formed flock is settled. Then, draw a portion from the top of each beaker and check the turbidity. At this time, you can compare turbidity, pH, and alkalinity of each jar. Finally, determine the optimal coagulant injection rate based on the lowest turbidity. Here is the result of the jar test practice. The result shows that the optimum injection rate is 15 ppm, the flock size is good, the turbidity is 0.81 NTU, the pH is 7.42, and the alkalinity is 26.8 ppm. In this class, we have explored various items such as sampling, basic water quality measurement, and jar test.